Good evening, everyone, and welcome to another of my live streams. So today we are going to have a second part of, I don't know, maybe 3 parts, or I think 3 parts, of the making of series of Arcane Sector Online, which was again the MMORPG game created for the Dragon CTF, created mostly by me. So there's that. Apart from that, today's moderator is KrzaQ, so you can see his nickname right here. Yep. And if you have any questions, then do let KrzaQ know, and KrzaQ will be able to telepathically let me know, and then I might be able to answer, or say I have no idea. Yeah, one of the two. If you're on our IRC, which is on irc3node.org #ginveilstream-en, then you can also type !Q and then the question, and that will also be passed to me. Yeah. Okay, let's do the usual stuff and basically start around 15 past. What am I missing today, however, is an open browser, so let me just open it. Okay, so this is KrzaQ's blog. Yep, and if you're into C++, then you should totally tell KrzaQ to write a new blog post. And I totally encourage you to visit. So one thing I actually wanted to mention is I started reading this book. Finally, I found some time, and well, I usually read quite a lot of books, but usually I read, I guess, fantasy books and science fiction and stuff like that. So yeah, but I actually got this on Google Play and started reading it, and it's actually amazing. So if you're into technical tricks on assembly level, then like absolutely read this book. It's amazing. The tricks which they used during making of Wolfenstein 3D is yeah, they're just like top notch. So totally check it out. Apart from that, actually, the new game engine Black Book was released some time ago, like a week ago, 2 weeks ago, about Doom. So yeah, that's another one you probably want to get. Cool. Apart from that, I don't know if I have too much to talk about, so let's see if there are any questions. Well, I guess I can talk about the CTFs, which were recently. Let me take a look. CTF time. No, not this one. CTF time. Yeah, here we go. And we took part in this one. HXP, which is Hackthorpe Shore CTF, is basically from one of the top CTF teams. They make a really cool event, and last year we really liked it, and this year it was also amazing. Rating weight was 42, and I already saw in the public voting that they are getting max scores passable, so next year they will have 63. And like Hellman says the crypto was cool, that means the crypto was actually amazing. Yeah, Hellman is really good in crypto, and he likes a challenge, so that means they had actually good challenges. Yeah, we were top 3, so yeah, our friends from P4 were top 2, so congrats on that. I'm ashamed to admit I do not know who Nobs is. Probably a top team, but yeah. In all honesty, I don't see them a lot. Well, congratulations to them for winning. That's really amazing. I mean, the quality of the challenges was really high. The level was really difficult. So well done on that. DCUA was then 4th, and Just Cut the Fish was 5th. Tasteless 6th. Another team which I don't know was 7th. Who are you? Oh, that would be a Taiwanese team. Congrats. I'm pretty sure I saw them on some CTFs. So yeah, that's pretty possible looking at their how they are doing. Actually, they're doing like really good. Top 2 here, top 5 here, top 1 in Bone to Win. So well done. And so on. Open to All is actually another team which is really interesting because, as the name implies, they are open to all players. They do not have like a really strict invitation only recruiting process. They basically accept anyone, and anyone can play with them, so they did that really well. And if you are new to CTFs, you might actually want to take a look at this team. Perfect. Now the challenges on this CTF were really interesting. I didn't have too much time to play, but I did play with there was I think it was called a cheat quest, which were a series of 4 challenges related to... Actually, is the page still online? I could show you because it's better to... It is online, perfect. Yeah, cheat quest of Hacksaw Shore. So, you basically got this, an image, and this image is actually telling... This is a game... oh, wait, you cannot see it. Let me fix that. Here we go. Yeah, okay, now... The image is of a Game Boy Advanced connected to a laptop. And the thing here, or the thing which you can see actually on this picture better, this is, it says it's an action replay. It's action replay or Game Shark. It's actually a cheat cartridge for Game Boy. So you could actually, well, send some cheats to it, and then it would modify in game, it would hook the game and modify values in memory. Basically, that's how it worked, and that allowed you, you know, to do the usual stuff of like invulnerability or like just being maxed out, the usual cheats in single player games, right? Now, the challenges were, all the 4 challenges were designed like that. Here is a pickup of whatever was sent to the device. And here is a binary of application which is used to communicate with the device. Have fun. And yeah, the first challenge was you actually had to dump the USB traffic from pickup, then analyze it, understand the protocol, and you would understand that they are sending some cheat codes to the device. It actually can do different things. You can send the cheat codes, but you can also like read the memory. In this case, it was sending the cheat codes, and what they did is, oh, by the way, the cheat codes are kind of funny. They're like pairs of D words, so like 2 32-bit values, and they're like encrypted, more like obfuscated actually than encrypted. And then the codes are somewhat meaningful, and there's a really, really huge list of all the cheat codes. I guess I can show you the list. Well, more like opcodes of the cheat codes, because they're like, I guess, hooking engine opcodes more than anything else. Hooking engine, yeah. So let me just find the proper file with my, oops, total commander help. Yeah, that's not going to help us. Here we go. Okay, and yeah, this is basically how after the obfuscation the opcodes looked like. So you had one D word, then you had another one, and like this, for example, was an 8-bit pointer RAM, right, where you encoded the address and the value into these 2 D words, and it would be executed at, like, for example, some conditions, because there were conditionals as well. If you scroll down, then there were, like, for example, if less than, and different conditionals and so on. So you had to figure out what's going on, and actually what game is the cheat for, because, well, again, it is a pretty generic thing. So it turned out that they were applying a cheat for Pokemon Emerald for Game Boy Advance, the US version. And yeah, you basically had to run the game, apply the cheats manually. Actually, the emulators allow you to do that. And then when you would start the game, it would just give you the flag. So that was the first challenge. Now, the second challenge was, I think the second challenge was kind of reversed, as in, let me open the second challenge. Yeah, it was, yeah, basically what they've done is they made screenshots and transmitted them over the wire, and you had to decode them. Now, the problem with these screenshots were that they weren't really screenshots. What they captured was data which was in VRAM and in different RAM areas related to video display on the console, which means you didn't have a frame buffer, but what you did have was the information how the screen is going to be constructed by the chipset of the Game Boy Advance, which would be, you know, you had the background layer, you have the sprites and so on, and the palette in another buffer and so on, and you had to put them together. Or, because I didn't do that, I was actually too lazy to do that. What I did is let me maybe show you my solution because I find it a little bit funny. After decoding, I put it in a, sorry, let me do it like this properly. Yeah, I put it basically in a C file, and I downloaded an SDK for Homebrew for Game Boy Advance. And yeah, so I put the 4 areas, which is the IO RAM, which is the setting for the screen, how it's supposed to be rendered, then the palette data, the color table, then the VRAM, which contained actually the I think the background stuff, and OAM, which contained the sprites, or the other way around, I'm not really sure. So I took them, put them into a static array, and then copied them basically into the RAM of the real device, and then and in case of IO registers, I actually just hand-picked which registers they want to copy. I didn't want to copy everything because that just didn't work. And then, yeah, like infinite loop. So after doing this, compiling it with Homebrew Kit, I put it in an emulator, and it would just like put the stuff in the RAM of the device, and the device would handle the rendering. Well, the emulated device in this case. So in the end, what you would get is, yeah, something like this. On one of the background layers, not all of them, but on one of the background layers, you could find, well, letters. And there were several screenshots transmitted, actually. So, yeah, so given that there were several screenshots, there were like 2 letters per screenshots, basically. So we just had to go through them and read all of them. So for example, this one is the end of a flag, which is H, and a closing curly bracket. So yeah, you know, it's CTF. I guess the task was to decode the image, but on a CTF, whatever gets you the flag is the proper way to do it in the end. So, so yeah. Then the third one, which I also did solve. Oh, actually for the second one, I think I got the first blood on it, which means, yeah, I was the first person to solve it, which I was pretty happy with. Because I totally had like 0 knowledge of Game Boy Advance before I started doing these challenges. Yeah. Oh, this was fun. You actually had to defeat 8 gym leaders in the Pokemon game to collect 8 pieces of the flag. Well, I actually did it in a little funny way, because once you understand how the patch which they applied to the game works, you could just start a random Pokemon battle. Then, when the battle is over, basically take a certain part of their patch and patch it in memory, and it would just tell you the piece of a flag, and then just repeat it 8 times, and you would get the full flag. I guess I have. I'm not sure if I have a screenshot of that actually saved, sorry. Yeah, then there was the 4th challenge, which was released in the last day, I believe, of the CTF, and which got 0 solves. It was, yeah, basically what they did, they created, again, you had to go in-game to a certain place, but you could cheat that, and I actually spoofed that, and then a person would tell you the flag. The problem is that the flag would only appear on the real device, on the real Game Boy, and not on an emulator. And I got to the point where I understood how the code was going to display the flag, but unfortunately the code was actually using encryption, and the keys for decrypting it were taken from special ROM places where they differed between an emulator and a real device. So yeah, and I basically, like, when I woke up really late at that day. I had like, I think, 2 hours to solve it, and I just didn't make it. So yeah, what was left for me is basically analyze the ROM of this device and figure out how does it do the hooking and how does it do the patching of the game to know what were the proper ROM values to decrypt the flag. So yeah. Anyway, I really loved these challenges. Like, these challenges were amazing. So totally, like, kudos and props for XHP for making the challenges on the CTF. I really enjoyed them. I learned a lot during solving these challenges related to Game Boy Advance, and I think they're like exemplary in how you create a CTF challenge, because At every stage, you knew what to do. There was pretty much no guessing, but it was technically challenging to get to the end. So that was fun. Yeah, it was also the first time I played ever a Pokemon game. My brother really liked them, but I never got to play them, so there's that. Okay, there are a couple of questions, so let's go quickly through the questions and then let's jump into the main topic, which again is the Arcane Sector making of part 2. Today we are going to talk about the game client. But let's start with the questions. Yeah. Mr. 7F Lead asks, can you use a UDP proxy to reverse a game? So basically, there's one problem with the question. I know what you mean, but just in case somebody is a little mixes up some things, you do not reverse the game per se. When you do a proxy, you reverse the protocol of the game, which are, two different things, because reversing a game, usually you think about reversing the binary of the game. And reversing the protocol is just reversing the communication protocol. It's actually kind of a legal issue at this point, as in you are allowed to reverse the protocol and re-implement it, but you are not allowed to reverse a game client and then re-implement it yourself, because that would be a copyright infringement, basically. Anyway, back to the point, which was the question, like, can you do a UDP proxy? Basically, yes, you can. The second part of the question is how to do it, like editing a host file, for example. Basically, whatever way works. I mean, if you have to patch the call to the connect, well, there isn't really a connect to, there is the send to and receive from functions, right? In case of UDP. So if you have to patch it and like change the IP or the port number, just do it. You can usually do some funny stuff with a firewall. Maybe you can reroute the UDP packet back to yourself to a different port using IP table rules. I'm not fully sure about that, but I think that should be possible, so do check out that option as well. It's probably the easiest one to do. Another is, as you mentioned, basically, if it tries to connect to a given domain name, then you can spoof it in your etc hosts file. It's exactly as you mentioned in the question. I guess there are some other ways, but these ways should be actually enough. The rest is thank you for your answer and also for the quality of your YouTube channel. Thank you for the kind words and for watching it. Okay, what about real CTF? I guess you mean real world CTF. It's a question from Frozen. I know it happened. I did see the pictures and it looked really, really amazing. But I have little to, like, almost no information on what actually happened there. So I don't know. I just saw like basically a video of folks doing a pwn-to-own style exploitation of, I think, a browser maybe or something else, where you had to pop a calc while other folks were watching, which is pretty fun. What CTFs can I recommend? That's the next question. That depends. I mean, if you are a beginner, then go with Pico CTF, and also look for other CTFs like Beginner Quest CTF from Google, and other CTFs which are beginner level, because that's the easiest way to do it. Apart from that, if you're advanced, then any CTF will do, basically. Look at the CTFs which have the most points on CTF time, because that usually means that the quality in previous years was really good, so it's usually more enjoyable in that case. I'm not saying that the low point CTFs are bad, because like new CTFs have low points, because that's how the point assignment works on CTF time. To check them out, but yeah, if you want to be sure of the quality, look for the top ranked CTFs basically on CTF time. And yeah, if you want to play but totally find a team, and like CTF is a team game, that's really fun, and if you play as a team. How do you dump it? Hook up an Arduino or just change the USB driver? So in case of a challenge, you actually get a pickup already of the dumped the dumped traffic. So you just had the pickup, you didn't have the device, right? Because it was an online CTF. Now, how they did the dump, actually both on Linux and on Windows, I'm pretty sure the default, like Wireshark can just dump it. And if Wireshark cannot do it on Windows, I'm pretty sure it can in recent versions. But there was also a similar application to Wireshark, Network Analyzer, I don't remember, from Microsoft. And I'm pretty sure you could do USB dumps there. So you don't have to even change the drivers. I mean, that's a solved problem, basically. Arduino wouldn't be too good for this, I think, because Arduino might be too slow to basically dump the traffic. And Arduino, I think I'm not fully sure, but I think the chipset for USB on Arduino is actually just doing like serial connection over USB. That's not even full USB. As in, it's a little bit simplified. Okay, so let's get to today's topic. There's one more question. Do I know how long the Google CTF Beginner's Quest will be online? I don't think end of life is scheduled at all for it, but it's not supported either. That being said, if something breaks, like ping the Google CTF stuff, and we might basically try to put it back online because it's useful for folks, right? Cool. So let's get back to today's topic. By the way, you can download the game sources on my GitHub, so that would be... Oh, I actually finally put a link to my GitHub page here, which was never here. I just put it yesterday there. Yeah, I need to update basically everything on my blog, basically everything. So yeah, if you go into repositories, then there is the Arcane Sector repository. So this is where the game is located. If you didn't watch my previous stream, or like 2 streams ago, or you don't follow me on Twitter or Facebook or wherever I spammed the internet with screens from the game, this is how the game looked like, basically. So it was an old school RPG, but I guess if you're watching second part of the video, you already know what is it, so I'm not going to talk about that. Now, today what I want to talk about is the client. Last time, so actually, let's do like this. Last time we did talk, I did say that there are 3 parts of a system, right? There is the thin client, which is basically the web client of the game, and it had the server side, which spawned a real client and handled the WebSockets, and that's what we talked in part 1. This was the thin client, the web thin client. Then there is the game client itself, which is written in C++, which does rendering of the 3D graphics and communicating with the server, and also chatting with whatever input-output library is attached to it, be it WebSockets and the thin web client, right? Or be it SDL2, depending on whether we are talking about the desktop or the web version. That really didn't matter for the client. And then there is the server, which was written in Python 2. It should have been written in Python 3, totally. But it's written in Python 2, which handles all the logic. There is almost no logic in the client apart from, like, you know, processing of events and the UI, like push the button or didn't push a button, because the rest of it is actually on the server. Like, you want to move, you request a move from the server, and the server tells you, okay, you moved, this is your new position. You want to cast a spell, then you click the spell and you send a request to the server. Dear server, I would like to cast a spell, and the server says, okay, no, because you have not enough mana. So yeah, there's that. And 3 parts, we discussed this in part 1. Today I'm going to talk about the client and how was it made, and the server is actually, I will talk in the 3rd part about how it's constructed. Now, the client itself is also client. Yeah, I totally cannot write. I know that I have this feature, client, perfect. Yeah, so the client was also split in 3 parts. I already chatted and discussed the I/O library last time, so I'm not going to talk about that. Then there is basically the game engine, which is the the game itself, right? Well, the game actually is rendering of graphics mostly and processing of I/O events, so they can be then forwarded to the networking part. And not all I/O events were forwarded to the networking part. Networking part is the third part, and it's the part which was connected to the server, right? And today I'm going to talk about both the game part and the net part of Arcane Sector. Yeah, for example, of an I/O event which is not forwarded to the network, that might be like just moving the mouse. Moving the mouse and usually means that you need to render the mouse pointer in a different place, and that is all done, well, kind of done in the game. In this part, in the second part. Actually, the mouse pointer was rendered in this part due to reasons, because it's actually faster, it's more responsive than having the game processing each move event. That being said, the game still had to process each move event, because if, for example, there was a button, right, and you wanted to, when you like hover over the button, you wanted it to lit up a little, then, well, the game actually had to handle that as well, because the game also handles the UI rendering. Now, but things like, for example, you want to move forward, so you push the up arrow or you push the W key, because both SAD and the arrow keys were basically supported. That would just like be passed to the game, and the game said, okay, you pushed the up arrow, you are in the context of the game and not the console, therefore I'm just sending a move event to the network that the player requested to move. So the support of such packets was rather minimal, and that went straight to the net to be sent to the servers. Now, when the server sends something, then the net module, basically the net thread, because actually two threads, there was a receiving thread and a sending thread, obviously. That's a typical model where you don't want to do pulls or don't want to use like select and don't want to use non-blocking sockets, where you actually have to do two threads to do that, to have blocking, one blocking socket, one thread sending, one thread receiving. So the net actually just got the packet, made sure that the packet is correct, and created a class around the packet, and then forwarded it to the game engine, and the game engine made adjustments to its internal state, and then when the next frame was rendered, the next frame would have the modified worldview, because actually the game itself has to have its own internal context, its own state. It needs to know how the world at this point looks like. Where are the closest actors, the mobiles, like enemies or other players, or and so on. It needs to also know where the items are located nearby. It needs to know what is in your inventory, or, for example, which screen are you on. Maybe you're displaying the console of the game, or maybe you're displaying the like, I don't know, the spell casting menu instead of the default inventory menu. So so the game has to have this context, and everything worked in a way that only the server, through networking events, was able to update it, with a small exception for clicking through the UI, because that was handled like between these two things. Now, as I mentioned already before, all the communication between these three places, between the I/O library, the game, and the network module, was handled by the messages. Basically, you have a list of messages which is initially empty, right? And then when one part creates a message, it's put on the list. Like, let's put here, and then maybe it creates another message, so it creates another message, and then it puts it again on the list. I think it's put in the back, but that doesn't really matter. The order doesn't really matter. I think it's like first come, first served. but whatever. And then when the other part is ready to process the messages, they are not always processing the messages. For example, if the engine is actually rendering a new frame and that takes a considerable amount of time, then it would not process the events. And when it would be done with the frame, it would send out the frame to the IO library, and it would then start processing the events. So yeah, it would pick up the first event, it would take it off the list, and it would start processing it. So this is basically the list here. It's a synchronized list. It's a synchronized queue. What that means is that you know, there must be no race conditions between two threads, which one would be writing to it, the other would be reading. So only one of these actions is possible at the same time. That's like typical, I guess, multi-threading design. And not really a complicated one at that. Now, what I did mention also is that the what I did, I'm looking in the chat. What I did mention also is that the game uses a software engine for rendering everything. From like in retrospect, I probably should have used just OpenGL or whatever, because you can use OpenGL on servers now. I wasn't really sure if you can use OpenGL on servers now, and I decided to just go for rendering everything in software. So that means that I was operating on, well, basically an array of bytes at the end, at the bottom of it, and I was, you know, doing modifications to it, which in the end looked like, yeah, like this, right? Or this. Now, that also means that when I started, the game didn't look too good, so I guess I can show you some screenshots. This is basically the first thing that got rendered, which is where, and I at this point, I opened screenshots from other similar games, like for example, Ishar, or let me maybe show you Ishar 3, the exact screenshot I was mostly looking at. I think it was this one. No. I just care about the screenshot. I do not. Okay, well, this is enough. Yeah, so I basically opened the screenshot and I noticed this is one wall and it ends here. And so it goes here basically, and this is another wall. And I guess like the next wall ends somewhere here, and so on, right? And I wanted to know in other games, like how much space do the players have between themselves and between the edge of the next frame. So I started to play around with the distances and with the perspective, right? To basically make sure that I get something similar, because I actually really liked the effect which they had. So if you look at this distance here, it's actually pretty similar to what's in Ishar 3. In this case, it's because that's what I wanted to achieve in my game as well. Now, if you're wondering how the 3D calculations are made, I actually made a function which is called pixel in 3D, and what it does, you give it a 3D coordinate and it gives you 2D coordinate of the pixel, and it also renders the pixel on the frame buffer. The like high-level formula for doing 3D into 2D casting is actually surprisingly simple, and that's if you have like XYZ in 3D, right? So this is 3D. Then you actually do, or actually this would be better. X by Z. This is your new X coordinate, and then Y by Z. So that means Z is actually the depth, like how far from you is something in that direction. So in this case, like this wall would have a higher Z value than, for example, the white wall. And that's basically the formula is at the bottom of this. But then you can, you know, do coefficients, right? To basically, you can, when you had like this X by Z, right? Maybe Z should be multiplied by some coefficient K, which makes the perspective more deep or more shallow, depending on the effect which you would like to achieve. Then, yeah, like same with the height basically, and so on. You also, by the way, because the 3D space was actually, in my case, in meters, right? So one in the 3D space, 1 unit in the 3D space was actually 1 meter. But also meant that it doesn't really work well with the screen, because the screen was it was like 428 times, so 428 columns times 240 scan lines, which means you actually have to somehow like cast one to the other, and like the distance between this part of the screen to this part of the screen on this exact scan line, I want it to be like give or take like 80 meters or something like that. I actually adjusted it a little as I went. So yeah, the formula which I gave you also has to be multiplied by whatever is the screen size. And there's another problem, is that the x, y, and z coordinates, basically, if z is 0, that means it's like here, basically like on the camera, right? In the player's eyes. If the z then increases, then it's farther and farther away. And for x and y, if x and y are 0, that means they're at the center of the screen. They're like here. And don't go away. And that's not true for the like pixels, right? Because in pixels, this is the 0, 0 place. So we also have to do some additions and subtractions to actually make sure that's also aligned. And also one thing which one decision I made, which was actually a stupid decision in retrospect, was I wanted the y coordinates to grow downward, which means that if this is 0, right, this is 0, then this would be like -1 and this would be +1. And I actually made this is +1, yeah, it's barely visible, but it's here. Anyway, yeah, I forgot this minus so many times and I was wondering why is something not rendering, but yeah. So having this done, then the next thing is actually doing some, well, let's see what else do I have here. Yeah, it's basically doing scan lines and rendering. So the image in the background is not a texture, it's just an image in the background, but that's it. Now, when you want to texture something, right, these are quads and I wanted textured quads. So to do that, what you have to do is, there are a couple of ways of texturing, and I actually wanted to be a little smart about it and not write a lot of texturing code because I know that's a pain. And thanks to optimizing it the way I did it, I probably did like 5 times the amount of work I would do if I would just texture it normally and write a normal texture mapping thing. But whatever. So in the end, I decided that I basically have 2 kinds of surfaces. These are flat surfaces laying on the ground. Like, for example, this is one, like the green tiles, right? These are flat surfaces. And also the ceilings here would be flat surfaces and the floors here as well. And also vertical walls. Like, this is a vertical wall, but like both this one, the larger one, the front one, the back one, but also the side walls, like side wall, this one. Right? These are all vertical walls. So basically, the only kinds of walls I had, the only kinds of 3D primitives or 3D objects I had in my scene were either vertical walls. They might be directed like this to the player or like this, but also at a weird angle, right? And flat surfaces, like laying on the ground or like being ceilings or something like that. So I decided to make 2 different drawing functions, one for the flat quads and the other one for the vertical walls. And due to that, I had to do the math calculations at the same time. Now, the texturing math calculations are simple. The problem with the calculations which I fell into was basically how to properly know when a given quad, when the given scan line ends on the screen. Because the way you do texturing in these kind of engines, right, is you take, for example, this quad, right? So where is this quad? Wow, this is totally not what I wanted. Oh, because I wanted to do this. Okay, so we take this quad, and then we we don't want to use the 3D to 2D transformation for each and every pixel, because that just doesn't make sense. It's some complicated math and it doesn't make sense. What you want to do is you want to do these calculations basically for each and every pixel on this line, and also on this line, so only on the side lines, right? And then, well, you basically can interpolate starting from this column up to this column in a given scan line, in one scan line. So you basically do the drawing from the left wall through to the right wall, like from the left side to the right side, going in rows. And that's actually kind of decreases the amount of math you can do. What the problem is here is that you remember our formula? Yes, sorry, that was like x by z. Now, what if z is negative? Then, if z is negative, that means something is in front of the camera. It's like behind the player, right? The player cannot see it. But in this formula, it would appear still on the screen, just like reversed. And that's not really what you want to do. So in cases like, for example, this plane here, or this quad here, you want to know where to stop rendering. And it gets a little more complicated even with the sidelines. So yeah, I basically had to spend some time just like away from the computer with my notebook open and start doing the transformations, and I have a few pages of math basically to just do that. That's not complicated math, but yeah, it's, you know, it's not like strictly programming. Just I had to take a break and do some math to actually properly do the view plane cooling. Yeah, so I can actually show you the math implemented, I guess. Let's go to the client, and it's everything. Yeah, I'm sorry, the code isn't beautiful, but the code is terrible. Please note that this is an MMORPG which I've written in 2 months, just using the evening times I had and night times, which wasn't too much, especially that the Google CTF finals was happening at the same time. So I was away for a couple of days in London, and I also had some conferences and some talks. So anyway, everything is in, I think it was called engine CC, which is a rather large file. Well, large as in this game large. And okay, yeah, this is the 3D point to 2D point which I described, which again is basically this with some with some maybe subtraction and maybe some coefficients here and there, but this is basically this formula. Then yeah, this is a scan line. Yeah, I think this is one of the math formulas. It doesn't look too complicated, but you actually have to figure out how to properly do stuff. And in the end, I reached like this formula, which again isn't super complicated, but it's more math than you usually do in programming. That being said, I probably could have found the formula on the internet, but yeah. Then I have a line drawing. Everything here is actually done, like rendered by the line drawing function, because there are no textures yet. Well, apart from the green area, because I was testing the flat surface rendering stuff. So yeah, I have the tile rendering function, which is again the flat surface, the flat quads, and I had the V quad, which is the vertical walls rendering. And it's about, I'm not going to go too deep into the code. You can analyze it, but actually don't, unless you want to write a software 3D engine, which there is no reason to do it. Yeah, what it boils down to at the end is basically you do some pre-calculations, and then you, starting from like the left edge up to the right edge, you basically render stuff. And the rendering itself is done by the Pixel 3D. Which again paints 1 pixel on the screen. Now the Pixel 3D is actually quite interesting because it does a lot of stuff. So okay, let me maybe show you the after it started working. It started to look like this, the problem was that the textures here was kind of like, you know, high frequency, not really smooth. So then I improved it and it started to look a little bit better. Like this, and I also added the fog effect. The fog effect is super easy to do. You basically take the Z and like if you have a spectrum, then the fog color is on this side and the color of the pixel is on this side, and you basically have to, well, depending on the Z coordinate, you just if Z is small, you just pick the color from here. If Z starts growing, you just go through the spectrum up to the fog color. So it's super easy way to, super cheap way to actually achieve a fog. And in the final game, let's find the proper screenshot. Yeah, it looks rather nice, I would say. Also, if you change the fog color to, for example, black, you can achieve the darkness in the corridor. That's just a black fog. Basically, there's no lightning effects here, so it's just a cheap trick to basically trick you all. Yeah. So technically, it's a massive multiplayer online RPG because the server supports whatever many players. That being said, it's not super optimal. Yeah, the CTF version supports 256 players, but you can scale it. And if you replace a couple of things, it could actually scale pretty well. Well, it doesn't scale per se. You can join more players to the server, because in MMORPGs, one thing which I didn't implement and what you want to do is you want to have multiple servers handling different regions of the world, for example, right? And that's not implemented because yeah, that was not in my model. Okay. Yeah, this is like another screenshot when I already had one function done with the you know, the flat surfaces, right? Then I started implementing the other function, which was rendering the walls. And this screenshot actually shows that I'm correctly drawing the walls. Correctly doing the calculations for the scan lines between like one part of the wall and the other, like left side of the wall and right side. And that's a little bit tricky because if you approach it a little different if you have, well, you can, depending on the math you go for. If you have like a wall which changes with the X coordinate and doesn't change with the Y coordinate at all, and then you have a wall here, like, you know, the one which is a side wall, which actually doesn't change at all with the X coordinate and only changes with the Z coordinate, right? So yeah, these kinds of walls basically. And yeah, this is like the basically last phase of the engine before I started to work on different things, because I actually started with a 3D engine for that. Yeah, basically this week it's only this week it will be Tuesday. Next week it will be normally Wednesday, because I'm not actually I won't be here on Wednesday, so like in front of my PC. So that's why I had to do it today. Okay, so let's look at the pixel 3D function. One more thing to note here is that, as I mentioned, the pixels here are rather smooth, and the effect is nice. It's not the high frequency, like missing some pixels in the interpolation kind of texturing. It's actually proper texturing. And you can achieve it in several ways. So the problem is like this: if you're new into 3D, then the problem with things which are far from you, right? So are like this. So you have a texture, right? And let's actually we can, I guess, close it. And the texture is like this big, right? And if the item is of this size on the screen, that's perfect, because you can basically render the texture on it 1-to-1. But if the item on the screen is actually this size, then what do, right? Well, you can do actually a couple of things. One of the things is for this, like this exact pixel here, this small red dot, yeah, small yellow dot here, you actually grab just this pixel here, right? And for this one, you grab this pixel. So this won't give you a nice effect. This will be the this will be this problem which I did show you before, but there are like a dark pixel here, and next to it is a white pixel, and that doesn't look really great. And the further you get, it looks more horrible actually. So there are a couple of ways to solve the problem. Well, you can, I guess, do not really take 1 pixel, but take like 2 pixels and then interpolate. But again, if your texture is this size and then you render something this size, then just taking 2 pixels, like this pixel and this pixel, is not really enough because it will still give the same effect. So the usual way you do it is you actually do MIP maps. A MIP map is a set of textures generated from one texture. For example, from this texture, you generate another texture which is half of the size. So this is, it's supposed to be half of the size. And you interpolate. So you take 4 pixels from this one, like 2 at the top, 2 at the bottom, and you do an average of them and render 1 pixel like that in the MIP map, right? And you do it for all the pixels. So you basically have the image shrunk down in a nice way by 2. And then you do the same repeatedly until you get like super small textures. So you do, again, this is twice of the size of this one. Then you do another one which is even smaller, and like another one which is even smaller, and you might stop somewhere around here. And then when you have to render something like this, what you can do is you can actually grab the like closest matching size texture, or even better, you can grab 2 and interpolate between them. So you grab 2, you say like, I want the color of this pixel on the texture, so you grab this pixel, you interpolate between them depending on what's the actual size ratio, right? And you insert the pixel here, and this is the way you do MIP mapping. Now, I didn't do it because I decided I want it to be done a little differently. What I've done actually is I didn't create any MIP maps. Maybe I should have, but I didn't care much about it. So if you look at the screens again, there is one thing to notice. Is that basically, since this game, you cannot move smoothly, right? You move like jumping one tile in the front or back, or like moving sideways, right? Always by the tile. That means that walls like this will always have the textures in the same place on the z-axis, on the depth axis, right? So like you can have the textures here, and then you can probably have them around here, but you cannot have them anywhere in between. So that means I could actually somewhat generate textures for every depth, but pre-generating them was, I didn't want to pre-generate them basically. So what I did in the end is basically when I first ask, like the system first asks for this texel, for the pixel on this texture, which is usually you call it a texel. So yeah, texture, pixel, whatever. Then it would actually calculate how large this 1 pixel is on the full size texture. So in this case, the full size texture would be, for example, like this. And the pixel itself would be of this size, right? Because yeah, this is smaller, this is larger, so the pixel here would actually be several pixels. And then it would do, the averaging and basically, sum up all the pixel values, like all the reds, all the blues, all the greens, and then divide them by the number of pixels. Number of pixels which are not transparent, because if the pixels are transparent, some of the pixels are transparent, some are not transparent, then that's you can ignore the transparent ones. Or maybe you don't want to ignore them, depending on what's your approach. I think I ignored the transparent ones because my engine was actually pretty slow when I created it, and I had to optimize. Sorry. Yeah. And then I cached it. So I put it in a map where the map was indexed by or keyed by the size of the texture. And yeah, I said if the texture is this size, then for this coordinate, this is basically the color of a pre-calculated pixel. So that means that the first time you enter, the client draws a wall at a given location, it has to do some heavy computation, because this is actually pretty heavy computation. Not super heavy, but on the heavier side. You don't want to do it every frame. But the next frame is actually going to be to just take it from the cache, from the texture cache, and that's it. So it's kind of like MIP mapping, but it was done in a more memory consuming and a more automated way. And the effect is pretty similar to what you would achieve by MIP mapping, but I think it's a little bit better, maybe slightly better. Yeah, so, okay, let's get back to the code, but what happened to my browser? Here we go. Okay, now actually the pixel 3D, because it's a commonly called function, I wanted to inline it at the beginning, so I created it in the .h file, but in the end I never, yeah, it's here. I never actually, it's too big, the compiler will not inline it, I'm pretty sure about that, so whatever. Yeah, well, the first thing it does is that it checks if the pixel is even on the screen. Because if the pixel is not on the screen, then whatever, right? You don't care if the pixel is off the screen. Then I, calculate the position of the pixel and index, right? So this is like a typical 2D array into 1D array coordinate transformation done for frame buffers. I guess you know the equation. Then if the pixel would not be rendered because the alpha channel, the transparency channel is 0, you return. You don't have to render it. Then you check if the Z buffer, because I actually have the Z buffer. What's the Z buffer? If you are new to 3D, a Z buffer is basically, so you have a frame buffer. A frame buffer has the colors of a pixel, right? And the Z buffer is also the array of the same size, but it actually contains the distance for a pixel from the viewer, from the camera. And in this case, for example, the Z buffer would contain like infinity here near the sky, then like, I don't know, like 25 meters, because again it's expressed in meters, the 3D coordinates are expressed in meters, so 25 meters here and here, then perhaps like 50 meters or whatever, like 70 meters here for the barely visible wall behind the fog, and like increasing from 0 to, I don't know, like 2 meters for this wall, a gradient basically. So, and yeah, and increasing also from 0 to whatever to 70 for the tiles here. So that's the Z buffer. You basically hold the distance. And if you hold the distance, you basically can say that ignore this, because you can turn off sometimes the Z buffer, but assuming it's turned on, if the pixel you want to render is actually further behind a pixel you already have rendered on your frame buffer. So think about, you have two walls, one behind the other, right? And for some reason the wall behind is rendered later. Then it actually checks if you should render the pixel at all, because maybe, just maybe, the pixel is behind something which was already rendered, and then you do not have to render it, you just exit. Now actually I have this check also in a function which is above for optimization basically, so this function isn't even entered, but in some cases is not rendered. Okay, then yeah, basically apart from the Z buffer, I also had an item buffer. So let's open some screenshots. Do I have any items here? I do not have any items. No, seriously, I'm pretty sure. Nope. Yeah, oh, perfect. So in this case, because do not look at the UI is not relevant actually, but this is an item, and I had an additional buffer which held a unique item ID per item, which is basically a 64-bit value, which I did already talk a little bit during my last videos about Arcane Sector Online. And yeah, it would, the buffer would be basically filled with an item ID when an item is being rendered. So it would be black everywhere, like 0 everywhere, but this sign would be, it would be filled like, you know, not just the outline, but everything would be filled with item ID. And that way, when you actually move your mouse on top of a sign, it would check like, hey, on screen and the item buffer, this is actually an item ID which is there. So display, like do something, display the name of the item, or if the player clicks on it, like wants to take an action, then you know the item ID which the player clicked on. And that's actually super useful to have, and it simplifies the code quite a lot. So that's that. Then basically merging typical, so this is typical merging of two colors in case of an alpha channel is used. I actually have a different function for that. That function should be inlined here. Unless the alpha is like fully opaque, not transparent at all, then just use the color. And then if the fog is enabled, yeah, do what I said with the fog, like get fog color depending on the Z, and merge it on top of the final color, because yeah, depending on this, it would return either lower or higher alpha value depending on the Z, and it would again be merged, like blended together with the final color, the texture color, or whatever you're rendering. Yeah, then there is some other stuff, and the color is finally applied in this place. This is where the color is finally put on the image, on the frame buffer. Oh, this is because the thing you saw, like well, maybe this one in the game, actual game, the whole screen was shifted -20 pixels up to make some room for the UI. So if you would compare this, like this is a little bit higher than just to make place for the UI. Yeah. So that's why there's the other if. Yeah. So as far as rendering the walls goes, it's as I said. Now, as in there are two functions to do that. But the rendering itself is done in multiple passes. I think there are like 5 passes when the rendering is done. And I guess it's better explainable on this screenshot. Now, let's, before we get there, let's actually move to the engine CC again. And there is a rather crazy function here. Okay, render at, engine render at. And it's basically, you give it the game state. This is the game context, the world which the game knows. You give it the map coordinates. These are coordinates on the map, right? And you give it the direction where the player is looking at. Like, is it north or is it east? Where is the player looking at? And yeah, and the goal of this function is basically to render a new frame. To do that, it resets the Z buffer, it resets the item buffer, and then depending on your map coordinates, it changes the color of the fog, and actually the coefficients of the fog, how dense is the fog as well. These actually are the coordinates of the labyrinth on the map. So if we look at the map again, let's run tiled. Tiled was again the map editor. It's an open source map editor which I used. So yeah, if you are in this maze here, then you want the fog to be black. You want it to be like this, to emulate darkness, right? Lack of light. But if you are somewhere like anywhere else, basically like here, or maybe in the inside of a house, then you don't want the fog to be black, because that would be like nighttime, right? You want it to be more or less the sky color, I guess. So actually the fog here also has a different reason to exist. It basically blends out the things which are not rendering anymore, because the engine doesn't render everything it sees. It renders up to, I think, 20 tiles in front of you. So yeah, everything else is behind the fog, which is a nice way to actually like just not render it. Now, yeah, and in this labyrinth, you wanted to have a black fog, that's why the color of the fog is actually black. And the coefficient of the fog is actually 5 here, here is 1, so it's much denser, the fog is much denser inside the labyrinth. Yeah, then depending on the coordinates, you actually, let's maybe do it like this. Depending on the coordinates, well, you want to render, you want to always render the map either from the back to the front or from the front to the back. But if you're looking in the east direction, from the back to the front might mean like higher x values and lower x values at the end of that large loop, right? But if you're looking, for example, north, then in that case that would be lower y values and higher y values, right? So that's why you have to have this, the coefficients for iterations, and then the stages. Yeah, and after like writing the stages, because initially I thought I will get away with just one stage, but I did some hacks later on and it turned out that I need to render the frame in 5 steps, basically render the frame 5 times and render different things on each pass. So yeah, perhaps do a display list, because normally in OpenGL and so on, the way you render a frame, you first get all the primitives, all the quads and so on you want to render, and you put it on a list. And then the engine goes through the list and does some optimizations and renders them, right? I just render everything, which means some optimizations I cannot do, because I don't have a list of which I could sort, for example. So that's not super good, but yeah. Anyway, I do totally ignore the Z buffer. I do fill it, but I don't use it for almost all of the stages apart from stage 4 and stage 5. Only on stage 4 and stage 5 I actually do render the Z buffer. And then it goes to, yeah, I also calculate the view count, because for example, if I would be standing here, right, like here, I said that I'm rendering up to 20 tiles, but I'm not rendering a quad like this, because that wouldn't make too much sense, right? It's more like a cone. The view is always a cone. So yeah, you basically have to calculate how many tiles do you have to render at this point and how many when the tile are super close. For example, if you look here again, right, there are only 3 tiles visible next to the players, like this tile on the left, then the center tile here, and the right tile. But if you look at the back, there are already like 1, 2, 3, 4, 5, 6, 7 tiles, and it actually grows quite fast when you render more tiles. So that's why you actually want to have this calculated as well. And yeah, this is the view cone. It's, yeah, easy math. And the coefficients here, I basically like just, manually sorted them out. Is it rendering good? No, it's too little, then I adjusted the coefficients and so on. Yeah. Then, well, you get from the map, from the world map, you basically you check if the coordinate is even on the world map. If it's not, then by default it was assumed that it's water. You're looking at water. So if you would be standing here, for example, and looking in either this direction, well, not really this direction, if you'd be looking in this direction, then you would just see water here, more water, everywhere water. Here you would see nothing, because, yeah, but you cannot stand on that part here. Though looking this direction, you will see a lot of water. And that's also what happened when you solved one of the challenges where you pushed the player off and the player actually teleported to the island on the other side. That you actually saw water here as well. So the default, if a tile is off the map, is just water. Yeah, default water. Depending, I think, on some things, but whatever. Yeah, and then what it got from the world, it got the tile ID. And if you look at the tile, it's not greatly visible, but the tiles are here. 0 is actually nothing, then 1 is grassland, 2 is water, 3 is mountains, 4 is sand, 6 is forest, 7 is stone road, or like road in mountains, like rocky road. Then 8 is a normal road, 9 is a wall, like building wall, and 10 is a floor, building floor. And yeah, so this is rendering here, nothing, grass, water, and so on. And for each type of a tile, the rendering is has its own function. Yeah, in some cases I also did some other stuff, but the important part here is to know two things. But if we look here, T, which is again the tile from the map, has a type, and the type is just this, what I told you. But T also has a different property, which it didn't have. It doesn't have it server side. It only exists in the map of the client, and that's actually the variant. Now the variant is an additional value, which I don't remember, but I think it's either 8-bit or 32 bits. I don't remember what I settled on at the end. And or maybe it's 16-bit, whatever. It's an additional value which has a meaning only for the rendering of a given tile. And if it doesn't have a special meaning, then it's basically random. So if you look at the game map of how it looks on the server side and how it looks on the client side. So on the client side, it looks like this. On the server side, it basically looks like looks like this, but without the colors. And on the client side, it looks a little bit different. Is this the... Yeah. Now, what's the map size? 512 by 768. And yeah. Yeah. So, yeah, this is how it looks like. And as you can see, it's pretty random, right? Like, why is it random? And that's because the variant is random in most places. As you can see, it's not random in case of mountains. Mountains are here, actually. And it's somewhat random in case of mountains, but it's not random in case of forests. So, weird things which you do for a game is basically what an effect I wanted to achieve is if you have a tile like here, which contains a forest, and it's basically like a forest. It contains a tree, and it's just one tree in the middle of a grassland, like, you know, there's a lot of grass here, right? Then I wanted to be only one tree here, only one tree. Well, this is the most terrible tree you probably saw. I can actually draw a tree. Yeah, perfect, tree. Yeah, anyway, so yeah, I wanted it to be one tree, only one tree. But then if you go deep into the forest, you start traveling like this road, for example, and you're, for example, here, I wanted the trees to be really thick, right? I wanted to be like 5 trees on, like next to each other on one tile. And to achieve that, I actually had to do map pre-processing to know what is the density of a forest. So that's one of the things which I did not expect starting to write the game, is that I will have to write some pre-processing to measure the density of a forest. It's not what you expect when you write this stuff. And that code is actually located in map exporting, and let's go over. Actually, we'll have to go back, but whatever. It's in the attic. Again, attic is not really attic, it's actually the world map files. I do have to rename it. And the export world is exactly which the stuff which contains the pre-processing. And then there is the where are you? Yeah, calc tree density. And it basically, the way it works is it checks from this, how close is it to a different tile, which is considered to be non-forest type, up to 15. And actually water is considered to be forest type, and road is also considered to be forest type. And also this is considered, and this is considered a forest type. So for example, I guess grass and water are not considered forest type. So from here, it would be only one tile, and that means the density is low, so render only one tree. But from here, it would be like quite a lot of tiles. It's not 15, but it's like 12 or something. So yeah, so rendered like 4 trees in a tile, and so on and so forth. So basically the tree density map would look like this. Let me open it. Let's mount. Okay. Okay, and yeah. So yeah, this is basically the tree density map, and this is also what you saw on the variant side. So this is where all the forests. There are some single trees here, but they have low density, so they're basically 0 density. And here I did a funny trick. I basically didn't want this forest to be super thick, so I just cut out, like, changed different trees to like grasslands, and that way the trees here, the forest here would never be as thick as the forest here, for example, right? Yeah, so that's one pre-processing which was done. The other pre-processing was related to the mountain heights, because I wanted the mountains to be rather low here, like, yeah, like player size basically. And as you go deeper and deeper into the mountain, I wanted the mountains to be like really huge. So I did basically the same thing, and another variant was filled, like variant layer, for the mountain height. So this is the height itself. As you can see, there is the path here, which is like, doesn't really have high height, but the brighter it gets, right, the higher the mountains are. But having it only like this the effect would be kind of funny. So I also added a randomness factor to it. So there's a randomness factor as well, which means that yeah, which basically means that there is some small differences between each tile. So I guess the best way, this is the proper moment for me to show it to you, actually. So let me start the server and let me connect the client to it. Okay, I just need to take a look which number of the client is it. Okay, here we go. Yeah, and yeah, we are probably in a perfect place anyway. Yeah, so again, I'm like, if I'm near the border of a forest, on one tile I actually see only one tree. But as I get deeper into the forest, there's still one tree on a tile. Then there are 2 trees on a tile. Then if I go deeper, there should be like 2 bushes, for example, and a tree. And then this tree is really close as well. And then there are like 3 trees here. Maybe there's another tree behind it, and so on. If I go deeper and deeper, there like the more trees are around me. And same with the mountain. But to show you the mountain, I actually have to go here. Yeah, I guess it was like maybe pretty visible from here. It's not the best place to show it. Why didn't I use OpenGL? Because I was kind of afraid that this was supposed to run on the server, like the client was supposed to be run on the server, and I was kind of afraid that I cannot use OpenGL there. Okay, I guess it's pretty visible here. Let's maybe, yeah. Like the further it gets, so the denser like the higher the mountains are, and also on the same place, basically there like random small variations between the heights to make it look a little bit better. Now, the thing I did mention is that there is no lightning system in the game. It actually doesn't. It doesn't have any lightning. So the question is like, why is this wall darker than this? So actually, I was reading the Wolfenstein 3D book, and it turns out they used exactly the same trick as I used, which is there are actually 2 textures. One is a dark texture, and the other one is a light texture. So just to show it to you. Wow, I have so many textures. Am I in the right direction? Yeah, here we go. Yeah, there's a light texture and a dark texture for the things, and depending on whether I'm rendering a side wall or a front wall, then the side walls always use the dark texture and the front always use the the other texture, like the light texture, and this gives an effect of actually there being like a more shady areas and more lighter areas, which is actually just an effect. That's the light, there is no lighting system at all. So oh, by the way, this runs in 120 FPS. That might be not visible, but it's actually like around 120 FPS. Yeah, so that's why basically if I look at this wall, it's shaded, but when I turn to that wall, it's light. It's not shaded anymore. Like same basically here. This is shaded, I turn around and it's not shaded anymore because this is shaded. So it's a funny trick, but it looks a little bit better. Now the problem with texturing here is that you can see when I go, then this thing moves up. And this gives really weird effect and the texture looks really horrible. That's because I ran out of time to implement proper texture scaling. And actually not really scaling of a texture, but more like UV mapping. There's totally no UV mapping and there should be UV mapping. Okay, so let's minimize this and let's go back to the code. So one more thing about the trees, because actually, apart from the density, there is one more funny problem which you have to solve. If you have, let's make it again. If you have a tile, right, and you have to put 5 trees, where do you put the trees? Well, you might put them like here, 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 and here, but that actually looks bad. And at certain angles, you might have just like empty space looking through all the forest up to like the end of the forest because you're just shooting between the trees. So what you want to do is you want to actually have this randomized, right? The positions of 5 trees, you want to have them randomized, but you cannot just do like, yeah, for all trees, just randomize the X and Y coordinate, because what you would get is you would get one tree on top of the other. And because like random, right? If you do several sets of these, that's what you get. I'm sorry. So what you want to define is you want to define how far the trees are supposed to be from each other, and always pick a position which is, well, this far from the other trees. But another thing which you don't want is you don't want a tree to be placed here, because what I'm drawing here is actually like the, what's it called? You know, the main part of the tree, like, okay, I have no idea how it's called. I'm sorry. My English is terrible. Trunk, yes, that's the word I was looking for. So what I've had drawn was the trunk of a tree, but the main part of a tree, right, the crown of a tree, actually is larger. So if you'd have one tree, for example, here, and the trunk would be like this because there are huge trees, that means that if you have another tile and you have another tile here, then technically the trees are not close to each other on the same tile, but they are really close to each other regardless of that on 2 tiles. So you do not want the tree to be close to the edge either. So you basically have to limit where you are randomizing and then take care of a position. So I guess like programming this kind of like a large game, right, is about solving such small funny problems which you would never think you would have to solve. So in the end, I basically generated several variants of how this is the client. Yeah, this is the client. Yeah, several variants of how where the trees could be located. Because I didn't want to use only one variant, I wanted to use several variants of locations depending on how many trees are there, and even for that I wanted several variants, because that just gives you a nicer effect for the forest. Sorry. Yeah. Okay. So let's go back to this. Okay, so again, the stages. When the function is called, it gets past the stage. And how the stages work is like this. I'm pretty sure I have it described somewhere. I know where I have it described, so let's look at this description. Yeah. it's, yeah. So first you render water, and then you render grassland, forest, and ground. Why is it like this? Because, as I said, the game is actually tiles, right? For example, if we look at the screenshots again, and yeah, it's pretty obvious that these are just tiles, like, or even better, the one, yeah, like this one, where the lines are still visible. But what I did is I actually decided to do a funny trick. Because if you, and let's see if I'm, yeah, no, this is already fixed. Also fixed. Yeah, here. Here is how the road looks like when it's just tiles. It looks a little horrible. You have these like straight lines, right? And that's not really great. So I actually cheated a little. And when you have a tile, the texture which I'm rendering, or the flat surface which I'm rendering, is actually larger. It's actually like this. And it has exactly, or almost exactly, the edges as I drawn. So the edges aren't like sharp, right? These are not sharp edges. These are like little broken edges with some alpha transparency. And thanks to that, you actually get this kind of road. It doesn't look super awesome, but it looks a little bit better because it's not like just a straight line. It's actually like you have this curved surface. But to yeah, it is I guess a little more visible here. And to have it drawn properly, you first need to draw a thing which is the only thing which doesn't have the curved surface, which is water. Water is the only thing which is just like straight lines. And then on top of that, I draw, without ignoring the Z buffer, I draw the sand. So the sand, as you see, has these nice, not sharp edges. And, oh, sorry, the sand is later, because if we look here, then, yeah, it's basically this is a tile of the grassland, and this is sand, this is grass. So the grass actually overflows to the tile of the, sorry, the sand overflows to the tile of the grass, not the other way around. Yeah. So yeah, so that's why you have to render the grassland, then the forest ground, only the ground, no trees, and also the wooden floor for houses, then the sand and rocky roads, and then the dirt roads. You have to actually have several stages for that, because otherwise they would, like, one would intersect with another in a really nasty way, and you would not get this somewhat nice, not straight line effect which I was aiming for. And at the end you render the verticals, so the building walls, the mountain walls, the trees, and all the items. And that's done, and you turn on the Z buffer and you start rendering that. And everything is basically done from the end, sorry, from the deep part. So the first these tiles would be drawn, the grass here, the road, and they would be drawn up until here, apart from items, because the items and the vertical walls, like these walls, because you actually want to use the Z buffer as much as possible. So you want to render something, for example, this wall. When you render this wall, you don't want the next wall, which is here, to be rendered in full. You want it to be rendered only in the part which you actually can see, so only this part, and you don't want this part to be rendered at all, because if I would be drawing from the back, that would mean that I would actually render the full wall here, and then again the full wall here, overwriting basically this, so this work would be lost. And that was what I was actually doing at the beginning, and my frames per second were actually seconds per frame. I had like, I don't know, like three frames per second, so it's okay, still in the frames per second territory, but not really a lot. But yeah, but when I switched it and rendered from the front to the from the front to the back, the Z-buffer optimizations really kicked in, and that saved a lot of computations, and it goes up to like 160 FPS, even when rendering mountains. Yeah. So actually, when I was doing when I was doing the mountains, there is like nothing in the engine which says that this has to be a straight line. I believe you can have the line like this, and I wanted actually the lines to be like that, and I didn't want, there's again nothing in the engine which says that this has to be a straight block. It could be like 3 blocks, like 1 block here, then a block which goes like this, and then a block which goes like this, and this would make the not, as you call it on the chat, a Minecraft look. It wouldn't be a Minecraft look. It would look much better, and I actually wanted to do that, but again I ran out of time before the CTF, because there is also some pre-processing here to know which are the edge walls and which are not the edge walls and so on. So yeah, in the end I didn't get to this, and it would actually look a lot nicer. I guess for next year I might be able to do it, because I'm pretty sure some variant of the game will be reused in the future. Okay, so let's go back here and look at an implementation, for example, of how the forest is being rendered. Oh, I remember was here. It actually, for the maze, because the maze uses the building walls, right, and it also uses the normal mountains, it added sorry, I'm mixing it. Not for this. For the rocky road, it actually, if the rocky road is on certain coordinates, draw the rocky road, but also draw a ceiling. So that's why you have a ceiling here. Again, for buildings, that's not what's happening. If you go into a building, for example, one building is there. Let's go there. There's a building here. Yeah, it's there. Yeah, so if you go here, then, well, you can see there is no ceiling, because I actually ran out of time and didn't program the wooden floor to be like, or some ceiling to be rendered for the buildings. And I also wanted to do that the same I did for the maze. It's a simple change, but yeah, you know. Okay, so let's look at how the forest is, for example, rendered. This is the most complicated function, which is here. If it's stage 1, then just render the grassland tile. Yeah, just because for each forest, that's actually an exit. Yeah, for each forest, you need to place the tree on the grassland tile, and then this is actually the texture of the tree. Then, if it's not stage 4, then don't render anything. We only render in stage 1, and then later on stage 4. And then don't render trees which are like right in front of you. So when I approach this tree, it actually disappears, because otherwise we would just have a screen full of a tree trunk, and we don't want it. So yeah, I didn't want that effect, so I just choose to hide the tree if we are standing on the same tile the tree is on. Then there are type of trees, right? And I have several types of trees, several images that actually show me. Sorry, I'm going to show you the textures for the trees. For example, yeah, like this tree. The textures are like super nice. The Trant, the graphic artist, like he knows what he's doing. Yeah, so here are some textures. Here is like a pine tree, and here's a dead tree, and here's also a bush. Where's the bush? Yeah, and there are like several types of bushes as well. Yeah, so basically I picked... the pre-processing also does another thing. When we look at the world map, I actually divided the forest in types. For example, this type of a forest is actually only pines. Only pine forest would be here displayed. If you go to this, only pines are displayed, like the various types of pines. If you go here, actually, where is it? Not here. Here, only dead trees would be displayed. And if you go here, I think it has only like leaf trees, and here are leaf trees only, and here are like a mixed trees. So, but also depends. When I have type, these are basically in-game sizes expressed in meters, so that will be like 4 meters something and so on. And this is the height. This is like 8 meters 60. Then I have sets of trees basically, which are basically tree types from the array above. These are the slots which I did tell you about, which where on the tile is the tree placed, which are computed by some Python script I've written. And then from the variant, it actually takes how many trees are there, which slot from this array to use, and again this is semi-random, it's actually random on the map, and which set to use, as in to use maybe mixed trees, or maybe do you want only dead trees, right? So like depending on this value from the variant, you actually choose the proper set. Yeah, and in the end you just basically render the trees, which is, yeah, you draw one V-quad with a proper texture with the proper coordinates of the top right and top and bottom left, basically, which are calculated from the tree position. So that's basically how rendering of a 3D works, whereas items are rendered and basically in a similar fashion, also using the Z buffer. I think after everything is already rendered, then the items are being rendered. So yeah. In stage 4, actually, the mobs and the items are being rendered, and only if they are in the viewing distance. And actually, item viewing distance differs from the wall viewing distance. I shouldn't have done that. I expected more items to be present in the game, but that's, yeah, I should totally not do it. That means that, for example, here, right, we know that like both the flasks and the door is an item actually. So if we move far away from it, it disappears, right? Because the viewing distance of an items is smaller than it is of other stuff, which again, it should not be the case. So actually there are two things here, because as you can see, the battles did not appear yet, right? So the game server itself sends the items starting from like some distance, and in case of doors, already the game has information that the doors are here, but actually the doors are rendered with the wall. Like the wall function actually checks if there is an item type door here, if there is, render the door. And yeah, the battles are rendered by a different function, that's why they appear 1 tile or 2 tiles later. And yeah, and in the end, that's it basically, that's how the frame is rendered, the 3D frame. And on top of that, actually, what's rendered is like the map. For example, the map, which you can see here, which is, I guess, quite easy, right, to render it. So there is not much talking about. Then the UI is rendered on top of, map is rendered as last. Then the UI is rendered like 3D, then the UI, and then the map as the last element. And yeah, like for example, when you hover over this icon, then the UI needs to know the mouse position and needs to highlight the book a little, right? And similar for like showing the text above it. One thing which I obviously had to write is the font rendering engine. So, and it's a couple of things, right? It's, first of all, I wanted to be able to draw colors and like to have several colors which you can use. But then there's another problem. What if you want to write something on a screen? This is a screen, and your text is actually this long. this long, yeah? So it exceeds the screen. Well, you obviously need to wrap it, and writing a text wrapping engine is another part which usually is really useful. So for example, if I say something, notice how when I'm saying something, this actually doesn't wrap, it changes the beginning into 3 dots. But when I, this isn't really, doesn't show it, I should make some spaces. Yeah. And then when you display it, it actually should know that, hey, the next word is actually rather long, so do not fit it here because it will not fit, render it in another line. So that's a word wrapping part of the font engine or text rendering engine, which you also had to write. And the other thing is that the font doesn't really have this nice outline, and I wanted it to have the outline, like the black outline next to the letters. And there is actually also a special function which, after the text is rendered, checks where the text is and renders the outline on top of it. So it's actually more readable, because otherwise the colorful text would not be readable on the screen at all. Yeah. So yeah, then there is the rendering of items, which in the end, yeah, I thought it would have to be much more complicated, but in the end why would it be complicated? Because I had functions to render textures, but items usually and commonly do not come in single textures, they come in sets, right? So in this case, if we do, where is the items? Where are my items? Okay, let's go through all textures. Not an item. Buttons. Yeah. Whatever. Yeah, if you actually go into the, this was the initial frame for the screen, and I actually used it for the console and requested for this, right? And requested another one for the game screen. So this is from OpenGameArt, but like the other stuff, like for example, this was made by Bertrand. Like I actually hired a graphic artist to do it, as I did mention. This one I did, please ignore. I like the gold ring. Okay, where are my items? Yeah, here are my items, perfect. So, as you can see, they actually come in sprites, in sets of items. So, if I would want to render a texture, and I did tell you already that I didn't have any UV mapping, like UV mapping allows you to select only one area of a texture. That means that, yeah, I basically had to deal somehow with it, and I had an additional function written to render a piece of an image. But in the end, what I did is I basically pre-processed this and split it into multiple textures as far as the game engine was concerned. So the game engine actually had multiple textures for like one texture per item. Yeah. So that's why initially, like, it actually was a little more complicated than when I commented it out. When drawing the UI is actually, the code here is most terrible, due to I didn't want to write a UI engine. Usually you have like like buttons, text fields, and so on and so on. So you basically create a window of a game window, right? The UI out of pieces, and then each piece is programmed. It's the same as like you have in HTML. You create a website out of text fields, out of forms, out of images, and so on. And then you can like do actions. If you click on this image, you can do something in JavaScript, right? And that's the proper way to do it. That's how it's done in the web browser. That's how it's done in WinAPI. That's how it's done in GTK, in Qt, and so on. And I didn't want to go that way because that means additional code. I actually written well, basically full UI engines at least twice in my life, so I know quite a lot about how much work is it. So I decided to just wing it and basically do everything manually. So these are not widgets, these are not controls, these are basically just images with some action on top of it when a mouse is hovering over them. Yeah, so that means that the code here is really horrible because it both contains the what happens when I, for example, click and hold on this book, right? I know that you can barely see the book, but please believe me, this is a book. Let's maybe make it a little bit smaller. Yeah. Or the backpack. This is what happens, and the logic for both me holding my mouse button on it and displaying the graphics is actually in the same function, and it should never be like that. It should actually be split into two different pieces of a system, but yeah, that's what happens if you're time pressured. It's actually quite long as well. And like everything is here, including if I get my mouse over the item which is on the 3D screen, a 3D screen is again something different, then it also is tasked with displaying this nice text here telling you what you are actually seeing, what you are pointing at. It also has some funny stuff. For example, when I hold something and I start to drag it, it also needs to be able to support that. So it's a weird place to put this logic, but it is there. And yeah, and that's basically the story of how a frame is how the frame is created. Yeah, the tooltip at the end. This means that the tooltip should be displayed as yellow. 13 is actually yellow, right? So the tooltips are always yellow. Yeah, and that's actually, I think, almost all of the code which is in the engine itself is what I described. There's like 2,000 lines of it, and there are some like additional files, but that's mostly the gist of it, what is responsible for rendering the game itself. Yeah, so I guess that's it for what I wanted to tell you today. Now, the next time we meet, I'm actually going to talk about the networking stuff and the server stuff. So basically how the server is created, how the packets are parsed on the client side, on the server side, and how do they communicate with each other, and also how stuff on the server side is made, right? Like, for example, how is it that if I like have this flask and I right click on it, I can select something, and then it changes the flask color and it says it's an unspecified potion 64, and so on and so forth. How does it happen on the server side? Because all of that logic is actually on the server side. The client only sends requests. It's like, for example, sends an item holding request, it sends a use item request and item selection request, but it doesn't know anything about potions, about what is this item, what does it what should it be used for, because that again is for the server to decide. So that's it. If you have any questions, let's go through them right now, and then we can round it up. Okay. So let me show the questions right here. Yeah. Okay. CTF Rookie, I already answered that question. How long the Google Beginner's Quest will be online? Yeah, there is. It should be online, but it's for a long time, but it's unsupported. But again, if it breaks, do let me know, or let us know actually. Mr. 7F, you can use select function to avoid having two threads. Yeah, I did mention that. I did mention that if you don't want to go the select and poll route, and you don't want to do non-blocking route, then you can do the two-thread route. Personally, I prefer the two-thread route because I do like to have a sending queue, which is kind of separate from the networking code. It's a matter of preference. In some cases, if you have a lot of sockets, then you probably, like for example, a server, right? You probably don't want to go the route of having two threads. Yeah, maybe in the server I actually went for the route of having two threads, but yeah, you probably want a server, a select then, because select works like this. You give it a set of file descriptors, basically, and it tells you which files descriptors have some data for you, or waits until they have some data and doesn't use the CPU power, right? So that's actually really nice. And having multiple threads has a similar effect, but select is actually much nicer on the server resources. But it depends on what do you want to do with it next. And I actually wanted to have processing in different threads, that kind of eases up my model. But in Python, that doesn't matter too much anyway. I guess in languages which have proper multi-threading, Python doesn't due to global interpreter lock, right? But that would be more efficient to have multiple threads in. I guess in this case for normal languages. I guess like using fibers would be even better, but whatever. Because then you save time on between when the thread is woken up and so on. Sadzonka Nienawiści writes, considering cyber warfare, do you think steganography is getting more important than encryption? It is a good question, I guess. So steganography it is an interesting question. I wouldn't say it's more important than encryption. Encryption will still be more important. That being said, for some uses, you might want to consider using steganography with cryptography. You do not use steganography by itself, in my opinion. You use steganography plus cryptography. So you basically encrypt something and then you hide it. Just hiding something unencrypted it's not the best way to go. But yeah, that depends on what you do, right? What program did you use to design the word map? That program is called Tiled, and you can find it on let's see, Tiled. Yeah. Tiled map editor. You can find it on mapeditor.org. It's open sourced. It works on, well, at least on Windows. I'm pretty sure it works on other operating system as well. And you can actually become a patron of the author, because the author is actively developing it and supporting it. So yeah, you can totally become a patron. Okay. The modulo operator is commonly used to limit random numbers. Those random numbers then tend towards certain values depending on the modulo argument. Is there a mathematical explanation? Well, I guess it's quite easy, right, to explain it. I mean, basically, what... let me actually show it in a hex editor, because this will be easiest, which sounds really weird, right? But let's assume that, let me create a file. And in this file, let's assume that we have a range of numbers, and the number of A letters I'm writing here actually expresses the range. So let's assume that we have a random number generator which generates 40 numbers, right? So it can generate 0 and it can generate like value 40, whatever. Okay, let me save it. And now I'm going to open in a hex editor, because a hex editor has a really cool feature. Okay, and I guess you can already see it. Now we do modulo some number, and the modulo is actually this number. So, and this is hexadecimal. Let's do modulo, I don't know, like, yeah, modulo 17, 10 hexadecimal, starting from 0, so that's actually 17 numbers. So this is modulo 17. And as you can see, there are like 2 values for, like 2 A's for this value, but there are 3 ones for this one. So this is just like how many numbers will wrap. The modulo will be actually good if the value of the modulo is actually that you divide by, right, is well, the same, is a multiply, no, the range is a multiply of the value you are using as modulo. So if this would be like this, please ignore this, because this is just an end of line, then that's perfect, right? You have 3 for each value. So if you select this value, then modulo the like 13, you will get 6. But if you have a different modulo, then you have some values which were 2 values and some values which were 3 values. And that's all to it. There is no other high math here. It's just that in some cases there are more values being present than in another way. The proper way to do it actually is to, like, if you want to select a random number, then with a proper distribution. So you don't want to have this effect of there being 3 values here, so it's more probable to select this value than to select these values, right? It's more probable to select these because there are 3 different values here. So the random number engine would select one of these values, and yeah, it has like a chance of like 50% more chance to select S than to select 6 than to select B. Now, the proper way to actually select a value of uniform distribution is to, when you detect that you get one of these values before modulo, you have to check it before modulo, then you randomize again. You basically disregard the result. You do not return a random number, you again roll the randomizing engine, and if one of the values which is in the green field, if it's here, falls out, then you do the modulo and you return. If one of the values here falls out, you disregard, you again run the randomizing engine and try it, make it select a different value. This is the proper way to do it. Yeah. Okay, let's switch to, yeah. If you could do this, why does the mountain look like straight out of Minecraft? Okay, I already addressed this. It was basically because like lack of time. I could, there's nothing in the engine which prevents me from doing better looking mountains. That doesn't mean proper mountains. The first bytes of the 64-bit valid pointer are never used. Could you use it to save the length of a reference array? Please don't kill me. Okay, so it's like this. Basically, okay, I need to check something. Okay. Never mind. But I kind of remember some paper about it. Anyway, long story short, yes, you can. So before using the pointer, you'd have to basically strip out that part, because otherwise, when you use the pointer, then it would, it would fail miserably, right? Because the CPU would complain, for example, that the value of the pointer is not canonical, and you get an exception. But apart from that, it is a good idea, kinda. As in, it is a good idea in the sense that, yes, there are some bits which are unused, and you could use them for random things, and that's a good thing. And that might actually improve security on one sense and do some other stuff. On the other sense, we already had this situation before on Windows. So it's like this. The memory model on Windows, on 32-bit Windows, is like this. You have 4 gigabytes, again, 32 bits, so no tricks. No, sorry, you do not see my desktop. Let me show it again. Okay, so you have 4 gigs, right? This is 4 gigs. And half of it was split to the kernel. This is the kernel land, and this is the user land. And the user land could use addresses from 0 up to 7F, and then like 6 more Fs, right? That means that 1 bit here was unused, so folks started saying that, okay, if this is the case, I'm going to use 1 bit to actually signal something, or this is a special kind of a pointer, for example. And yeah, then, because like, I mean, this is 2 gigabytes. And at the time, folks said like, yeah, like nobody is going to have more than 2 gigabytes of RAM in their system. This is like a huge amount, so nobody will have more. Like guaranteed, nobody not in like the lifetime of this product. Obviously, a few years after that, folks started to get more than 2 gigs of RAM, and like on the servers, like for databases and so on, they wanted to have applications which use more than 2 gigs in the user space, because like the kernel doesn't use 2 gigs of of the virtual space. The kernel could easily squeeze in like 1 gig of, or like even less space. So the kernel could fit here, and then you could use this part for having 3 gigs of address space, right? But if the Windows devs would actually just switch the kernel to be in this model now, right? So to only occupy the top gigabyte of the RAM and to give 3 gigs to the user, that means that the standard libraries for memory allocation would start returning addresses here. And if an application, which again is actually using the topmost bit for some weird reason to signal something, would start like receiving pointers from the operating system which have this bit set, it might go bananas, it might go crazy, it might crash. And that's what actually happened from what I know. Given that Microsoft actually did implement this, but it was hidden, it was hidden when the 32-bit systems was relevant under configuration value. So you had to specify a boot time flag for Windows to say it, please run the kernel in this model where you have 3 gigabytes for the user space and 1 gigabyte for the kernel space. And on top of that, binary had to have a flag set. The exe file had another flag set, which was large address aware, but would mark the applications which actually know that they can use 3 gigabytes and they are not doing anything funky. Obviously, the older applications would not have this flag set, and the operating system would still fake them, like tell them, only you have 2 gigabytes. You have only 2 gigabytes, so you will never get a pointer which has the highest bit set, just for backward compatibility. Later it was maybe changed, and you can actually specify where did you want to have the boundary. Did you want to have a boundary, for example, on the 2.5 gig, or maybe you wanted to have the boundary at 3.5 gig if the kernel is able to store that amount of space. So, and later Windows version, you can actually specify it even more, how much space do you want to have in user land. But again, the large address aware flag was required for binaries to actually be able to use it. And to back to your question, let's not make the same mistake again. Basically, with using the bits in pointers for weird stuff. I guess what we should be using is fat pointers, so-called fat pointers. We are sometimes using them in C++ anyway. It's not visible for the programmers, but sometimes the pointers are twice as large because they contain like some more information, especially when some weird inheritance is going on with objects. Fat pointers is one way to implement it actually in C++. So yeah, ideally, let's use fat pointers, unless the CPU vendors agree on using the upper bits for something or the lower bits for something. And yeah, so that's my long answer. It is a good idea. There are places where you might actually want to use those bits, but as a general, let's be careful about it. Okay, next question from Dohan. CTF infrastructure question today, or the next one. Let's make them on the next one, because I guess the server side is more relevant to that. That being said, I might not be able to answer too many questions about the infrastructure because I made some assumptions about the infrastructures, but it was later implemented by Valis and by Emlen, I believe, so, and maybe another person. So they know more stuff about the infrastructure than I do. And for Google CTF, actually, also different folks did it. Guest writes, let's assume that you have got a computer virus. No, my computer virus. Okay. What are the first 3 steps to get confirmed? You don't have exe samples, just some process in the system. I guess the easiest way, if you're starting to suspect something, is you can assume that it's a stupid virus. If it's a stupid virus, then things gets a little bit easier, and you basically just send all the executables that are running in your system to VirusTotal and see if anything weird comes up. That would be what I would do, actually. Yeah, then that doesn't cover for smart viruses, which actually act as rootkits and don't show up in your process list, right? And doesn't cover for things which are not on VirusTotal. And also VirusTotal tends to have false positives, so be careful what you are actually removing from your system. Yeah, but that would be the first try. If I would still suspect there's a virus and VirusTotal would not say anything, then I would probably, you know, like shut down the machine, take the disk out and start to do forensic stuff on it. Like see if there is, for example, anything which didn't show up in the process list, but in like, you know, the best way is actually to do a blue screen, and then, because that gives you a memory dump, and then using that memory dump, you can use volatility framework to, for example, list the processes, seeing them from the kernel. Or you can attach a kernel debugger if you have another machine and also get a proper list of processes from the kernel in several ways, which are should not be spoofable ideally. There are still ways to hide. Rootkits are actually super interesting, and yeah, like sometimes you just might lose, right? So you have to take that into account. Didn't VirusTotal shut down their service? I'm pretty sure they didn't. I'm pretty sure it's still out there. Let's see. Where's my browser? Here we go. VirusTotal is still running, as you can see. Oh, API desktop. Fun fact, do you know that I've actually written this application? It's not the best application, I'm sorry. But yeah, when I was working for HispaSec, I've written it. Then I know that some folks at VirusTotal actually, at HispaSec actually corrected the application, so it's probably better now than it was then. I guess the biggest plus of the application was that it was actually super small, because it was, yeah, I've written it in like pure Windows API, no heavy library, so it was super small, like several, I don't know, like 20 kilobytes or maybe a little more. Yeah, it's super useful because it actually displays the processes and you can just upload them. Yeah. I know nothing about VirusTotal shutting down. You might have more information than me. I've heard that addresses, UB, memory sanitizers, and GCC are not as good as those in CLang. Can you confirm? Yeah, from what I know, the ones in GCC are actually lagging behind in the in code, because actually the ones in GCC is the same code base which is in CLang and Clang, right? But in they are being developed actively by folks like from, you know, the LLVM Clang or CLang scene, and not from the GCC scene, and they are backported to GCC, so therefore they are lagging behind in versions on GCC side, and I'm not sure where was the last time they actually merged them. Okay, I guess that's it. So thank you for today. Thank you to KrzaQ for being my moderator today, and thank you to all of you for actually coming. And I guess I see you next week on Wednesday, normally on Wednesday. And I will continue with the third part of making Arcane Sector Online. Yeah, so that's it. I'm going to leave you with some music. If you are not working on the AI bots for tanks mission, then you might want to start. There is some more information on the ending screen. And that's it. That's it. So yeah, happy hacking and see you next time. Bye bye. Oh, and thank you for the donation, Marble. Ala Makota. Just in time, basically. Okay, see you everyone next time.